What if I told you that a Chinese startup has just unveiled the most articulated humanoid robot ever built? Capable of sensing a touch of less than 10 grams on its skin, moving its fingers with the precision of a pianist, and costing less than an affordable family car. Well, this is already a reality. Kinetix AI has just revealed the KAI, and what lies behind this robot will make you rethink everything you thought you knew about the future of robotics. In the next few minutes, you will understand how this system works, why experts are debating it frantically, and what fundamental question still has no answer. Do you want to understand everything? Then watch the video until the end, and I will explain it all. But first, subscribe to the channel so you stay informed about the latest news in robotics. At a conference called Gifted, held in Shenzhen, China, the startup Kinetix AI took the stage with two dressed humanoid robots, one in white, the other in black, seated in modern armchairs as if they were at a job interview. They introduced themselves, they conversed with each other, and with that, the company announced to the world the KAI, the humanoid robot, with the greatest number of degrees of freedom ever placed in a human-sized body. What is a degree of freedom? Think of it this way. Every joint in your body that can move independently is a degree of freedom. Your shoulder has several, your elbow has one, your fingers have many. Together, the movements of the human body add up to approximately 200 to 250 degrees of freedom. The most advanced humanoid robots on the current market, such as the Atlas from Boston Dynamics and the Optimus from Tesla, operate with between 28 and 56 degrees of freedom. The KAI arrives with 115. In simple terms, it is capable of moving in a way that no human-sized robot had ever achieved before. Kinetix AI did not emerge from nowhere. The company was founded by veteran engineers from the original research group at XPENG, the Chinese electric vehicle manufacturer that also developed the humanoid robot called Iron. In other words, the creators of the KAI already had experience on the front lines of Chinese robotics. The Gifted conference went far beyond a technical presentation. It was a declaration of intent. The company wants the KAI to enter homes, shops, hotels, and customer service centers, not heavy factories. And for this, Kinetix AI set a bold price target, less than $40,000 per unit. This places the KAI in a market potentially accessible to small and medium-sized businesses in the services sector. Mass production is scheduled for the end of 2026, taking advantage of the dense industrial ecosystem of the Shenzhen-Hong Kong corridor, one of the most advanced high-technology manufacturing regions on the planet. What nobody expected was the level of technical detail revealed. The company did not present merely a flashy prototype with rehearsed movements. It opened up the system architecture, detailed its sensors, explained its data collection strategy, and described the intelligence model that powers the robot. And it is exactly there that the story becomes even more interesting, because how the KAI works on the inside is just as surprising as its appearance on the outside. To understand the KAI, it is useful to think in three layers: the body, the senses, and the brain. Try to build an articulated doll that moves like a real human being. To do that, you would need each segment of the body to have joints capable of rotating, tilting, and bending in multiple directions. In conventional robots, this is simplified to the extreme. They move, but in a mechanical and predictable way. The shoulder of the KAI, for example, can rise between -20 and 0 degrees and perform embracing movements between -15 and 0 degrees. The waist can tilt from -15 up to 75 degrees. The neck rotates up to 50 degrees. Each of these specifications exists so that the robot can perform natural movements in environments designed for humans, picking up objects above its head, bending down to reach the floor, turning its torso while walking. The hands are the most ambitious part of the entire project. Each hand of the KAI has 36 degrees of freedom, 22 of which are active, controlled by motors, and 14 passive, which function as mechanical shock absorbers. The 14 passive degrees work like natural shock absorbers. The very mechanical structure of the hand controls force automatically, without needing any computer calculation. It is the same reason why you can hold an egg without breaking it. Your tendons distribute the pressure on their own, without you thinking about it. The practical result: the hand of the KAI does not need to decide how to hold a fragile glass or a soft object. The mechanics already do that work. For comparison, the third generation, Optimus from Tesla, has 22 degrees of freedom per hand. The KAI has 36, a considerable advance. The second layer is the skin. The KAI is wrapped in a tactile synthetic skin containing 18,000 sensing points distributed across the entire body. The system can detect forces as small as 0.1 Newton, the equivalent of the weight of approximately 10 grams on the skin. In practice, this means the robot can perceive when it is touching something fragile, when it is close to making contact with a person, or when the force applied in a task exceeds what is necessary. This is what the company calls manipulation with haptic awareness. That is, the ability to feel the physical world and adjust actions in real time based on that sensation. The battery also plays an important safety function. With a capacity of 1.7 kilowatt-hours, it uses semi-solid technology, a halfway point between common lithium-ion batteries and solid-state batteries, which are still the future of the field. In practice, this means far less risk of overheating and fire. which is essential for a robot that will coexist with people inside a home. The third layer is intelligence. Kinetix AI developed what it calls the KAI World Model, a closed system made up of 3 modules: base, action, and evaluation. The base module processes perceptions of the environment. The action module generates candidate trajectories, that is, options for how the robot could move to carry out a task. The evaluation module checks, before any movement is executed, whether that trajectory is safe and stable. It is a continuous cycle of planning, checking, and acting. To feed this system with quality data, the company created the KAI Halo, a lightweight device worn on the head by human operators during their daily routines. While these people carry out common tasks, clearing a table, carrying bags, organizing shelves, the device captures first-person video, body posture, and 3-dimensional point clouds of the environment. The result is a training data set generated in a natural way, based on how humans actually move and interact with objects in the real world, and not from artificial motion capture sessions in a studio. This choice matters because the biggest bottleneck in modern robotics is not the hardware, it is the data. Teaching a robot to act reliably in unpredictable environments requires enormous volumes of real examples. The KAI Halo strategy is an intelligent attempt to collect this data continuously and cheaply, making the process scalable. Other competitors have invested in computer simulations to generate synthetic data. Kinetix AI bet on real-world data collected by humans in first person. What makes this moment possible now and not before? 3 factors converge: the miniaturization of high-precision actuators that have become cheaper over recent years, the advancement of vision-language action models that allow robots to understand complex commands, and the maturity of the Chinese manufacturing ecosystem, capable of producing sophisticated components with unprecedented cost and speed. The KAI represents direct pressure on sectors that have historically depended on intensive human labor: customer service, retail, home services, and hospitality. A robot with that level of manual dexterity, tactile capability, and a price below $40,000 is not just a laboratory experiment. It is a product that is starting to make economic sense for medium-sized companies. Professions such as receptionist, shop assistant, and simple service attendant fall directly within the sights of this technology. According to Morgan Stanley, the global market for humanoid robots could reach $5 trillion by 2050, with more than 1 billion units in operation. Whoever enters this market early, whether as a manufacturer, component supplier, or user company, has a window of competitive advantage that is closing rapidly. On the other hand, the KAI opens up real opportunities for elderly care and home assistance in rapidly aging populations, such as those of China and Japan. A robot capable of sensing light touches, adjusting force when holding a fragile object, and operating safely near vulnerable people could help fill part of the caregiver shortage that these countries will face in the coming decades. The challenge lies in demonstrating reliability outside the controlled environment of the laboratory. And that is precisely the obstacle that will separate promising projects from products that actually reach the hands of consumers. The global robotics community reacted with a mixture of technical admiration and pragmatic skepticism. On one hand, the number of 115 degrees of freedom is genuinely impressive. No humanoid robot the size of a person had ever come close to that. On the other hand, experts remind us that degrees of freedom alone do not tell the complete story. An articulated system is only as good as its ability to control each of those degrees reliably, in real time, without freezing, falling, or causing accidents. The more joints there are, the more complex the control software becomes, and the harder it is to guarantee stability outside of anticipated situations. The question engineers are asking is, can the KAI world model coordinate 115 degrees of freedom robustly in unpredictable domestic environments? For now, that answer will only come with real-world operating time. There is also the question of transparency in demonstrations. Videos of Chinese humanoid robots have frequently been questioned regarding the actual degree of real autonomy versus human remote operation. Kinetix AI did not disclose detailed metrics on autonomous performance, task completion rates, operating time without intervention, percentage of failures. This data will be essential for any serious evaluation of the product when mass production begins. The KAA enters a competitive market, but with a well-defined positioning. The Atlas from Boston Dynamics leads in technical performance and already has signed contracts, but costs up to 10 times more. The Optimus from Tesla promises a lower price, yet accumulates delays and still does not operate autonomously. The Figure 03 has more mature software and consolidated industrial partnerships, but less capable hands. On the Chinese side, the Unitree robot is the cheapest and most accessible, while Agibot dominated sales volume in 2025, both focused on industry and logistics. The KAI bets on a combination that does not yet exist in the market: high mechanical sophistication, a price below $40,000, and a focus on services and domestic use. The great differentiating advantage of the KAI lies in the combination of 3 factors that no competitor brings together simultaneously. The greatest number of degrees of freedom among existing humanoids, a sensory skin with 18,000 touch points, and a target price below $40,000 for the services and domestic use market. The evident disadvantage is that the company does not yet have a track record of large-scale deployment nor public metrics of autonomous performance. As TechCrunch points out, Chinese hardware advances fast, but the software, the physical intelligence that gives the project its title, is still in development. The KAI may be the most articulated robot in the world. Whether it will also be the most reliable, only time will tell. The KAI from Kinetix AI is not just another humanoid robot in a race that accumulates dozens of contenders every month. It is a technical proposition that pushes the limits of what is understood as possible in terms of articulation, tactile sensing, and data collection strategy, all with a price that makes the product potentially viable for the services market, not only for laboratories and automobile factories. Launched on April 26, 2026 in Shenzhen, the robot arrives at a moment when China consolidates its dominance over the manufacturing of humanoids, responsible for approximately 90% of units sold globally in 2025. And when the debate about the impact of this technology on the labor market has ceased to be speculation and become public policy. The question that remains, and on which I want to hear your opinion in the comments, is this. Would you trust a robot with 115 degrees of freedom and 18,000 touch sensors to work inside your home or in the place where you work? And what would be the acceptable limit of autonomy for this machine? Leave your opinion in the comments. If the video was useful, give it a like and subscribe to the channel so you do not miss the next ones. See you next time.